Hello, in this video we're going to look at a strange looking utility function given by the following form. So here again is that utility function, and just following the rules of exponents, putting the x and y terms in the denominator, where x is units of good x and y is units of good y. This utility function, although looking strange, is quite reasonable. Utility increases with the consumptions of good x and y. So as x and y increase, utility is going up. Utility ranges from a negative infinity when x and y are 0, and utility will approach 0 as x and y get bigger. So again, as x and y get bigger, utility becomes a smaller negative number, so utility is increasing. The marginal utilities are positive, so if we were to take the partial derivative of this utility function with respect to good x, we get x to the minus 2 power, or 1 over x squared. So given a value of x here, marginal utility of good x is positive, and it diminishes with increases in the consumption of good x. Likewise, the marginal utility of good y is positive, and it too displays diminishing marginal utility. As y goes up, marginal utility falls. If we want to calculate the marginal rate of substitution, we're going to just take the marginal utility of good x and divide it by the marginal utility of good y, and we get y squared over x squared. Let's do a utility maximization problem with this utility function. Let's maximize utility subject to the consumer's budget constraint that the consumer has $120 of income, the price of good x is $1 per unit, and the price of good y is $4 per unit. Utility maximization can be solved by setting the marginal rate of substitution equal to the ratio of the prices. So substituting in, from the last screen we saw the marginal rate of substitution is what we got here on the left-hand side, and putting in the prices for good x and good y. And now we'll just simplify this, multiplying everything through by 4 and multiplying everything through by x squared. Leaves us with this. Taking the square root of both sides, x equals 2y. We're going to take this x equals 2y and we're going to plug it into the budget constraint. Rewriting the budget constraint, $120 of income equals the price of good x times x. So since the price of good x is 1, we just got x. Plus the price of good y times units of good y. Where I have an x here, I'm now going to substitute in 2y. So 120 equals 2y plus 4y. So 6y equals 120. Dividing through by 6, y equals 20. And I'm just going to plug this 20 back into this equation over here to get x. So x equals 40. So our utility maximizing consumption bundle is for the consumer to buy 20 units of good y and 40 units of good x. Okay, I hope you found this video helpful.